Okay, so we're going to give this one a shot right here. How do we graph tangent of x minus pi over 4 minus 1? And notice the pi over 4 is in parentheses right here. Well, the first thing you want to do is figure out the quotations, amplitude. Now, tangent really doesn't have amplitude, but it definitely can be stretched or compressed. That happens when you multiply something right in front of tangent. That's what will go here in the amplitude. Well, nothing's in front there, so I'm going to put a 1 right here, right in front of the tangent. Okay, now that we have that, let's find the next part. Oh, what do I want to draw? Here we go. The next part that you want to find is the period. Now, the period for tangent is unique. The period for tangent is equal to pi divided by the b. Okay, and the b is the thing that would be multiplied after factored or unfactored in front of the x. No. Is there anything being multiplied by this x? No. It's just a 1. Okay. Check it out. So you take the 1 and you put that in for your b. So you got pi over 1 is your answer for your period. Pi over 1, just pi, right? Okay. And then, woo, woo. Okay. Did you guys hear that? The next thing we want to figure out is, I want to figure out the phase shift. How much does it mean moved left or right? That's determined right here. Because it's negative, right there, because it's negative, it is moving to the right. Because it's pi over 4, it's moving to the right, pi over 4. So the phase shift is right. I should do this different color. Oh, get out of my way. Okay, right. Right, pi over 4. Okay. And the vertical shift, the last thing is the vertical shift. Let's see. That's determined by this one right here. What that is pretty much it's the up and down. It's going on up and down. This phase shift is the left and right. In this situation, it is going down 1. So vertical shift is -1 or down 1. Okay. So now with all this information, we're going to try to graph this function right here. Okay. And the key thing for graphing this function is that first you need to know what just the normal parent function looks like, then just tangent. So what I'm going to do is I'm going to first graph the tangent function, y equals tangent of x, and once I graph that, we're going to start to implement some of these changes to it, the phase shift and the vertical shift right here. Okay, so let's just graph that function, tangent of x. First, we'll just kind of put some dashes down in here. Now, tangent has a native period of pi, okay? So it always repeats itself after pi. Another thing you need to know about tangent is its kind of native period happens right in between here in this little section, right there. That's where the first just tangent of theta happens. So it's got a vertical asymptote going on right there. Let's see if I can get a vertical asymptote. It's not, I want it to be good. And we got to make that a dotted line. How do we make that a dot? It's like type. Nope. Nope. Okay, I'll just delete that. Delete. There we go. So let's put a little dotted line right here. It's got a vertical asymptote right there, and right there. And these values are, this is pi over 2, negative pi over 2. And tangent actually goes from the bottom to the top. So it looks like this. It crosses over there at 0, and it goes up to the top. Okay? And then, because it's got just natively has a period of pi, this repeats itself again, every pi. So if it happened at pi over 2, it's going to happen again at pi over 2 plus pi. And pi over 2 plus pi is 3 pi over 2 right here. And there it's going to have another vertical asymptote. And it's going to repeat itself one more time. So it goes there, goes to that center point, comes it up. Okay, arrows. And this can happen again. 3 pi over 2, then it's going to happen again at 5 pi over 2. And it's going to happen again at 7 pi over 2. It's going to happen again at 9 pi over 2. Okay. And it's even going to happen at negative 3 pi over 2. So forth and so on forever and ever, right? I'm not going to draw all of them. You're just going to get kind of the picture of this, what this is going to look like. So remember, right now, just as a refresher, I am not graphing this. I'm graphing tangent of x, and we're going to modify it. We're going to change things around, okay? Let me put one more in right here so you can kind of see what's going to happen. So it goes up. There we go. Now, let's make things change, okay? Let's focus on the phase shift first, right here. We're going to focus on this phase shift. This phase shift says move everything over to the right, right? Everything over to the right, pi over 4. So what is pi over 4 to the right? If this is pi over 2, pi over 4 would be half that distance. See right there. Okay, I'm going to put these little dashes in. Which means everything you just graphed, you just got to really shift it over to the right by that much. So see this little area right here? See if I can get that in there. Get there. Okay. That's there. That's there. This could be shifted from here to here. Right there. So I'm going to draw my new graph. This where it crosses x-axis should now cross right there. And see this horizontal vertical asymptote? That should now be right here. So here's my new graph. I'm going to do it in red. This new vertical asymptote is right there. This new vertical asymptote is now right here. And my new function goes right through there. Okay. See how it got shifted to the right? Everything got shifted to the right. Just a quarter. The same thing is going to happen to this vertical asymptote that's got shifted over to the right. And this point that was on here is now going to be shifted. It's going to go through that. So here's my new function right there. And now this got shifted over to the right again. So here's my new vertical asymptote. This vertical asymptote is now shifted to the right, pi over 4. And now it's going to curve back up like that. Get the arrows in there. And one last time, this point right here got shifted to the right for right there. And your vertical asymptote got shifted over pi over 4. And so that's going up like that. Right there. Okay. So that took care of this pi over 4. Now, let's do this minus 1. What that minus 1 does is it takes every point on this new red graph right here, every point here and here on this red graph, this one right there, and what it does is and this one too, all of them, it shifts it all down, a value of 1. So let's just kind of put a value of 1. If this is pi over 2, that's about a little bit less than 1, or a little bit more than 1. So 1 would be probably at this height, because pi over 2, pi is 3, and then divided by 2. So this is 1.5, so I would expect 1 to be about here, maybe around here on the graph. Let's put it right there. That's 1, or negative 1, and here's 1 right there. Okay, so now this point right here, I'm going to highlight them. This middle point, right there, right there, right there, right there. I like to focus on those. Those all have to be shifted down to this new point. I'm going to put it in blue. This new point right there. That point right there is going to be shifted down by 1. I hit a 1. Now, these vertical asymptotes, these are just vertical up to infinity and negative infinity. If you just were to shift these down, remember those tapeworms, if you were to shift it down, it doesn't change them. Same thing happens with these. These will not change. So the vertical asymptotes will stay where they're at. You just have to take this function right here, this red function, and just drop every point down. So this is kind of the new center point right here. So a graph of it will look something like this. Like that. Now remember, I'm not an artist, guys. I'm doing the best I can. Just so you guys know, those that are taking calculus, this point right here is an inflection point where it goes from concave down to concave up. So when you take calculus, you're going to remember that. Then I taught you a little calculus here. Concave down and concave up, right there. So there's your new graph. Remember, your new graph is the blue one, right here. That's your final result. This graph, this blue graph, represents this. Right there. We got one more right there. That one I could have probably done a little bit better. One more right there, okay? And again, this repeats on forever this way and forever this way. But that's how you can graph a function like this right here. What I'm going to do now is I'm going to go down. I'm going to show you how to do this function down here in the next, cotangent of x over 2 plus 1.